Hi. So my name is Belize, and I'm a software engineer. I'm going to talk about building apps on TV and wearable. So for the summary, I'm going to make a quick reminder: what is Flutter? What can it do for you? I'm going to talk about TV and wearable, a very weird devices. A project I made for this event. So the demo with that, a few feedbacks about the development part, and a conclusion about TV and wearable with Flutter. So a quick reminder, Flutter is based on Dart, which is an object-oriented programming language. It's very easy to learn if you come from where with React, JavaScript, TypeScript, modern language. It's very easy to learn. So it's open source, well documented, very inclusive with a large community. Actually, Flutter has 153k stars compared to React Native, which has only it has 110k. So I think 2 years ago it went over React Native. So it makes beautiful apps. It has its own render engine, which is Kia, and it's going to be to change during this year, I think. And it's very productive. I'm going to show you why after. So just to check the evolution of Flutter, it starts very slow. I think the community wasn't big at that time, and just people try, and the community bigger and you have new features. You have, for example, no safety, something that Kotlin already has, and also it was for that. And for Flutter, you have the desktop compatibility, the web, and so it's stable on Windows, macOS, and Linux. And last Wednesday, they announced Dart 3 that enable 100% of safety, records, and class modifiers. And we have Flutter 3.10 WebAssembly. So now I don't know if it's stable now, but you can compile on web using WebAssembly. And on iOS, they enable Flutter, which is the new render engine. Only for iOS. I think it's a beta for Android. So Flutter is cross-platform. So it can compile for Android, iOS, mobile tablets, and for web, for desktop, Windows, macOS, Linux, Chrome OS. And embedded with Car, Raspberry, RM. But in every presentation, we only mentioned that, and I wanted to add 2 things, which is TV and wearable. They never talk about them, and it's possible, actually. So let's talk about TV and wearable. So just to give you a context of what is a TV, what is a watch, it's actually a phone, but it has a slower hardware. So for the TV, you have only 4 cores. For the Pixel Watch, you have only 2. It's based on old Android. It's not new like every year and stuff. So you will never have a problem with the API. And the Google TV doesn't have any battery, so you don't have energy consuming issues. For the watch, you have a small battery. So compared to phone, which is maybe 4,000, here you only have 200 something. So on the TV, you have Full HD, 4K support, which is a lot. You need a big CPU, GPU for that. And for the screen for the watch is so small. It's like a 9 years ago screen. Also for the connection, we have something very fast. You can charge video, you can load videos and photos. And for the watch, you have a small like a small connection. And also internet is coming through Bluetooth, not Wi-Fi, but Wi-Fi at home, it works. So for the TV, you have to know that you control everything through a remote. So you only have a D-pad with a select button. So it only gives you 5 buttons to navigate. Compared to a phone, you have a finger, everything, plus a back button and home. And you have to consider that also it's a big screen. So, but Flutter gives you something for that. I will show you later. For watch, so it's small for sure. You don't have back button, so you have to consider also. And you have a lot of pixels, but the density is very big, so you don't have much space. You have to design something smaller than mobile. And also it's very slow because it's using Bluetooth through internet through Bluetooth. But if you have a 4G chip, it will go through 4G, I think. Not sure about that. Never tried. So for the development part, both of them use debugging over Wi-Fi. So you just connect. So if you're Android developer or mobile developer, you have ADB that can create a link to your phone, to Android, and you can do it wireless. So it was very well. You can debug. You can have a hard reload with Flutter through Wi-Fi. Just for the watch, you have to pair before. It recognizes your laptop, then after that you can connect to it. You have 2 different ports, so you have to precise the port which is different, and that's it. So if you combine, it just works, but it's just an app inside the system. For the TV, you have to add the lean back launcher that make your apps appear in the launcher in the big screen. Without it, you have to go to the settings, apps and stuff, and then you will have the apps showing. So it's only one XML code to put in the manifest. So the project I made, I started the 1st of May, so when I knew that I'm going to do the event. So we're in Montreal, so I based this project on Le Journal de Montréal. So based on the website, I tried to make it on a mobile, on the TV, and then on the watch. So I tried to use the Journal de Montréal design, the red bar, I tried to have the font, the square thing, the white, and stuff. I consume them RSS feed, so it's free. I just consume it. And the goal of this app is to try to understand how you can do the UX UI of the different screens. So the first issue I had is the device detection. So on Flutter, you have platforms that give you some attributes that give you the system. So you have is Linux, Mac, and stuff, but they are all on Android. So when you do is Android, it's true for everything. So you have to find a way to detect if it's a wearable, is it a TV, or is it a phone or not. So then I was like, okay, when you use a mobile and you try to do a tablet or web, you just go to the media query and try to check the width. Is it small, is it big, is it medium and stuff. But I was like, maybe if you check the aspect ratio and you say it's strictly 16:9, it can be a TV, it works. And then if you add, okay, I want 1920 by 1080, it can work. But if you have a phone that have the same shape, the head, the same height and width, it doesn't work. So you have a TV on the phone, it's weird. So you have, for that, you have multiple solutions. The first solution would be create three different projects, and you create a Flutter project for everything. So you have a strict separation, that's good. You know exactly what you are building. It works, I think. But the thing, if it's you go to a professional way, how are you going to make everything? I don't know. How are you going to organize your folders and the project repo? So you have to choose between the mono or multi-repo. Maybe you will have you will have also a duplicated bus spec. So if you have a dependency that is duplicated, you have to update every bus spec, every project, and you have to make sure that all the builder name is the same and stuff. Maybe you will have different builder name, different project. And also you have to make sure that the UI is shared to every project. So you have a fourth repo just for the UI and create dependencies between them. Maybe it can be a solution. The second solution is the compilation time. So when you build the app, so you have one code base, and with one line of CLI, you can define that, oh, okay, my type is TV, where, or if it's nothing, it will be by default mobile. It works, so that's good because you have a constant inside your project that give you always the same data, the type. The good thing is you only have one project for all the devices, or maybe you can do it with multiple main file. So main underscore the TV the where dot. And the same thing during the compilation, you just select the code file -f and file. The problem is, it's not really a problem, it's just I try to find something. During the CI/CD, you have to make sure that, okay, I select the good file or the right .define environment, variable environment, and that's it. And make sure also that all the developers have this small thing, or you have to explain them, or I don't know. The third solution would be a package. So you have a package which is package info plus. It gives you information about the system, what your system has inside. So, what is it? Okay, so you have the system features that give you all the features that your device has. So usually you have Bluetooth communication, phone, DL, phone features, and inside, I will show you after, you have type, television, type, watch, but they don't have, but for example, the TV doesn't have the watch and stuff. So that's a way you can, on the runtime, detect the device you're on. So I just make an extension on the Android device info, and then I can get the device, and I just check in the list of the system features if I have the TV or the watch. So that's good because it's a Flutter integration. It will be inside the code, and you can manipulate things. When it's in, you can maybe check if there's something else you want. I don't know, but you can compute more things. And the same thing, it's only one code, and for all the devices. Actually, I don't have any cons. Maybe if you have after, you can give me one, but it's very flexible. I don't have any cons. There's another subject, which is the remote for the TV. For the TV, so Android Flutter give you something which is logical keyboard key, and it give you all a big list of all the keyboard on the laptop or on PC. So you have to maybe just choose them and create a function that only choose the one you want to control, so up, down, right, left, and select. It detects also if you repeat, so if you hold the button, it can be another behavior, so you have to check. So with .3, you can just destructure the event. You say, I want the repeat, I want the logical key from the raw key event. And then you create a recall on the switch, and if it matches any of the values, it will handle it will execute the function. And onKey has the ignore and handle. So if you ignore something, so you have a focus tree in Flutter, and it goes from the bottom to the top. So if you don't handle it, the event just go to the top. If you say it handle, it will start to grow the tree, and so your action will just be executed and just stop. If you only return handle every time, you will block your UI. If it's something you don't want to do. So I'm going to show you. So I just want to show you first the website I base my development. So it's just Journal de Montréal. It has a header, square everywhere. It has some sections. So I call it this part sections and this part more categories. I didn't know how to call that. So it has different code based on the sections. It has on the side a drawer, and you see like every section has a color, so it's important for the game. You will know. So I'm going to show you on the mobile first. So emulation on Windows 11 is kind of weird. So if it crashes, I have to start it again. Okay. So here, so it's the home page. So you see, I just call the OSS field. I get the information. I just show it. I create a widget, article card, which is only that, only one square. You can tap. It gives you a button shape. You can share it, or you can just open it on the web view. How do I go again? So I try to reproduce everything, like the drawer, the size, the font, and also some behaviors. So I can switch. So for example, if I go to sports, you can see that all the colors change. So that's big changes with material free. So Flutter has the material free layout, and when you change, for example, the primary color, it will change everything for you. So I just tell him to just change the color of the app bar, even the text here. So I don't have to precise everywhere the color, specify the color. So now I'm going to show you on TV how it looks. So this one crashed, so I have to just start it again. TV. And you see the website is kind of has an issue. It takes some time. Okay. So actually, I tried to make my own design, just something that I can display. And here, okay, so I'm just going to open the remote. So that's what I was talking about. The XML line, it allows you to have this icon here. If not, it won't appear. So that's how it looks. So just to compare here. So all the small sections are on top. So Flutter already handle the remote kind of natively. So you don't have to do anything about this, the right and left. It will, when you press left, for example, he will try to find a widget which is on the left, a component which is on the left, without precising what you want to do exactly. So if I go down, a good example, if I go here, I go down, it's not the same. He just tries to find the closest one and try to match the widget. So you can go right, you can go down. You can, for example, go to football, select, and it will filter and show you all the football thing. So you see there's a big difference between this design and this design. Here you don't have on the TV you don't have the drawer, you have to think about how, okay, I have a menu, I have some subsection, how can I display it and how can it be easy to navigate inside? Okay. Now I'm going to show you on where. So where is here? You see, the TV just shut down, just crashed. And here is the watch. So how can you go from this to this? So first you have to, so on a watch is very slow, it's not powerful, it only has 2 cores. And the GPU also is not made for printing a lot of image or computing too much. So first you have to remove the image. I tried with the image. First, the image they post on the feed is very big. So it just slows down. For example, here you only have 3 articles, so it will call 3 times the server to get the image, for example. But when I start this app, actually there's 5 requests because they have different subsections. So here I'm on the actuality section. So to switch, I just press on the title and on the logo. And then here I have kind of a native navigation. So I can go to CWE. Oh, no. But no. Okay, another one spot. Yeah, okay. So same, it will change the color. So this app on watch actually reached the 60 FPS on the Pixel Watch. So it's a very good thing. It has low and small hardware, but it reached 60 FPS here. It's very good. Even on the emulation part. Even here it's a little bit laggy, but here not. It's very fast. So just to show you a bit of code, so I thought I was talking about the system features. So I extract the data I can have. For example, a TV on emulation. You can have a lot of things. I'm going to zoom in. So you have the leanback, which is the launcher. You have the Wi-Fi and stuff. And somewhere, hardware, software, you have the TV. I don't know where, but I get it. But that's where it's here. Where is it here? If you find it, tell me. 90?
90, 91, 18, 9.
Here?
Yeah.
Okay, maybe, yeah. It's not the one I was looking for, but yeah, I think it's this. And the same, like, I have one Google well, Chromecast, Google TV, and have the same thing. You will find the same features inside. For the watch, same. So you have a lot of things: the brand, the devices, the pixels, and also here you will have the Wi-Fi. Oh, here, type watch. And on the phone, you don't have all of this. So it's an easy way to know which device you're in. I can talk about this. So the device layer builder. So I created an inherited widget that allow me to just take the information of what device I'm on and then apply it logical thing. And then I have the section page them. So I don't know the naming is bad maybe, but it gives me the color of the section. So I give to this widget the section I'm in, but I call it the category, and with a map which is here, I just map the section based the colors based on the section I'm in. So I just check, okay, I'm on the mode, so it will be a green thing. And to handle all the devices, so I just do a context the devices, and I just return the right widget, which can be Wear, TV, or mobile. That's it for the demo. So for the feedbacks, the thing is you have the same code for all devices, so it's good for the business logic. You only write it once, and then it will go for everyone. It makes you think about optimization. So first you try on mobile, you will do your stuff. You go on TV, it's kind of similar performance, and then you go to the watch and you have a lot of problems. So when you do for watch, you will change many things that impact the architecture. So you do a lot of optimization for the views, for I don't know, calling APIs, maybe not 4, but only 1 per section. So buildings for slow and small devices allow you to increase the optimization for viewers. But then you have the ecosystem design. So when you develop for mobile or for website, the mobile is the smaller screen, so you take it as a reference, mobile first. But when you have a watch, you try to make it similar to the other devices. You want maybe later make them communicate each other. So it's a good exercise. It's not only one device; it's 3 different devices. So for the TV development, what you have to do, it's an animation feedback. So it's a big screen. So imagine you have a whole wall, an app. You click, and then you go from a black screen to a white screen with animation. It would just kill your eyes. So try to make things go on fade or slide or make something bigger, smaller, just move. Because it's very bright, and it can be bright and very hurtful. You have to learn focus, but the widget, because you have to handle everything with the keyboard. So okay, I don't know if you noticed, but when I move, there's no animation, and also there's some section that doesn't move. So maybe I have to focus in another way on some sections. There's the section name was hidden, so you have to learn how it works behind. And also, yeah, so it's UI, UX, and UI keyboard first. In the don't, I don't know. Like actually, if you have suggestions, maybe. But it's very fast. It's like a slow mobile. It's not. Everything works. So for the wearable part, there's a lot of things to see. So try to make small contents, very small, only text, colors if you want, but maybe not animation. So try to make something static. But keep it simple. Yeah, simple navigation, like just one drawer that comes on the side, and that's it. And vertical navigation maybe. You have to show time. Like you don't have to forget that you're using a device that has a main purpose first, which is time. So put time. It's very important. If not, I don't know. It's not natural. You have to exit the app and go back just to check the time and go back to the app. Setting content and using memory cache. So this part is more for information. So the watch is very slow. So when you get the image or data, just keep it in memory. It's good because you don't use your watch for an app that often. So just cache it in memory. It's already very good. So for my part, I use Dalio, intercept the request, and I send the request, I intercept the response, I put it on the side, and when later I have the same request, I just give back the same thing. When I close the app, it will go again to the server side. For images, you have where is it? No, it's not this one. Oh, yeah, it has. Yeah, it's here. So you have a package that called cached network image. Inside it's already cached. You don't have to do anything. Just use this widget and you will cache your images. What you don't have to do is image gallery. So don't scroll over a lot of images. You will have a very slow app. It will go, if you do that, it will go to heavy processing. So just a gallery is already a heavy processing. So you're just going to drain your battery, and it goes very fast. Maybe in 1 hour you almost did 70%. It's not made for that. And also, if you want to make a dating app on watch, you cannot say yes, just because the navigation is made in a way that when you swipe right, you just exit the app completely. And Flutter is based on one activity. So you have one activity with multiple pages on Flutter, you swipe right, you just exit everything. So no right. So for the conclusion, yeah, so for watch and TV, it works for sure, but it's not completely ready. It's still missing some maybe Wear OS implementation, API implementation. I don't know what, but maybe just navigation part is a good example. For the packages, you have Wear. It gives you the shape of the Wear, so is it round, is it square? And also, is it always on or not? So your screen can go black and white. It can give you, okay, ambient mode or not. Wearable rotating is for the small wheel on the side on the Pixel Watch. So it just gives you a widget which is like list view. You just give a controller and it will control this small part of the watch. So the next step of this kind of project, or maybe your personal project, you have to try to communicate with the phone. So I think with platform channel and method channel, you can just communicate through the native APIs. It will work for sure, but it's just as some development. I think you already have one package for that, but I'm not sure. Also for the watch again, Impeller, which is the new render engine, it will be very fast. We have, like, even with only text, it's already 60 FPS with some lag. So I think with Impeller it will be good, so good. So what works and what doesn't work now on Flutter, using Flutter. So if you create a text field on the where, you will have, I think, a bug. It will crash because the watch doesn't have a keyboard that comes from button. It's kind of like activity. It's completely on top of the watch. So I think it's just a thing. It's just like suggestion. I think it's possible to trigger the keyboard natively, faking a native keyboard. I don't know how it works, but I think it's possible. And then maybe you can get the callback from the keyboard and push it to Flutter. I'm not sure. For the native navigation, I saw some examples. I know that with Flutter you can cache the engine, and you can push it natively a new activity with Flutter, the same engine, but with a different route. So you will go to another page, but with another activity. So that if you swipe right, you're still on the first activity, which is the main activity. The watch faces, I'm not sure. I don't know how it was behind, but I know that it rendered something. If the app can go to ambient mode, so I think it can work for watch face. It's a suggestion. I don't know if someone has already tried or know how it works. Maybe you can give some details. What doesn't work is Apple TV and WatchOS, which is no, I don't think it's completely similar to iOS, so that's why it doesn't work. Maybe they have their own components, maybe, I don't know. I did some research on Android Auto, not the automotive, the one you connect your phone. And this one, I don't think it works because Android Auto has 3 types of data. You have the video. If they separate everything, the video, the data, and the audio. So it's a completely different thing, architecture. So thank you. Hope you enjoy. So do you have any question? You can ask me on LinkedIn or maybe just join the Discord.
Anyone have questions?
Okay. Yeah.
So yeah, when you try to design, all you think with the pixel, what are you trying to do with pixel? Like 1000 for a computer or for TV? I know, you said with the watch was 450 by 450, but what about the others?
Okay, so you will have the pixels, but Flutter have a layer on top which gives you DPI. So you won't have. So the pixel doesn't really matter. And so, for example, the TV, you will have full HD resolution. You go on the phone, it will be the same. So you cannot recognize which one is which one. So that's it. There's nothing else. Does it answer? Or?
Yeah, it's totally different, but yeah, I got it.
Okay.
Maybe one more question.
Thanks for the presentation. I see that you manage to know exactly what is the type of device we give an system. do you think it's possible to have somehow an environment variable in order to, when you push to your repository for your CI/CD pipeline, if you want to make, for instance, a specific demo for the business, you want just to deploy for one specific devices?
Yeah. So it's the solution too. So at the compile time, you have dot define that add one environment variable to dot, and inside dot you just string dot from environment. You just you put type, and it will give you the string where on TV. So it's exactly that.
Okay. It's related to the
Yeah.
type. Yeah. Okay.
Or maybe you have multiple type. You have multiple main file. It's two different way, which is the same because you just can predefine it.
Thank you.
Yeah.